are at the last start. I was going to do some demos from the phone, but it doesn't look like that's going to be an option today. But we'll get started. And if you're interested, we can look at actual code instead of actually what it does. But anyway, I'm here for Geographic Approach to Android development. And let me introduce myself. My name is Dan O'Neill. And I work for a company called ESRI, which is a GIS software company based out in Southern California. And my role with that, I've worked on a lot of the server products, and most recently I lead the Android SDK product, which is a mapping and GIS extension to the Android libraries. You can find me on some of these places. The top one is our developer group at ESRI. Get involved. Obviously, I'm on GitHub, do open source there, Google+, and on Twitter. So the agenda I wanted to go over today was GIS and this geographic approach. Explain a little bit about that and how that works, manifests itself through some of the things we do in our whole ecosystem of software, but most tailored to our Android APIs and SDKs. Part of that is geographic analysis, which includes things that you would expect out of most mapping APIs, location, routing, and maybe not so many of measuring and that sort of thing. There's an ACT part of this where we'll talk a little bit about a portal API that allows you to connect to some of the things that you, it's an acquisition API within the Android SDK. I had a maps that I was going to demo, maybe we'll look at some code there at that point. And then I wanted to go into offline patterns. In the mapping world, we have this term offline, but in reality, that was sort of the de facto way you work with maps. You didn't connect to services and all that. So in the modern approach, there's service-based data, and there's ways to provision data to your device. You can do some of these things local to your device. We also have an extension, and we can extend our API into, say, some open source spec and create layers based on those specs. So I was going to discuss a little bit about that. And then follow up and finish off with the ArcGIS Android tools that are available to you and that were built with a lot of this stuff. Okay, so straight away we'll start with the GIS and the geographic approach. This is essentially 5 things involved with this, and that is to ask, acquire, examine, analyze, and act. And this really goes to a broad range of doing anything with sort of a geographic approach, but I'm going to put it towards developing mobile applications on Android. So the ask part is very much getting familiar with the fact that asking questions of the data that you need to solve your problems from a location perspective or from a spatial perspective, and recognizing that that adds value to almost any business process. Acquiring data is essentially whether those services there's services available to get access to that data, or links available to that data, or do I need to have that data locally in a database or some sort of file system so that I can access it. The Android API we'll be introducing you today actually has acquisition APIs that you could potentially take data from one source and bring it to another. Examining data is a little bit outside of the Android world necessarily, but from an ArcGIS perspective, isn't it? Other parts of the software program. But it's about how data is organized and how it corresponds to the physical world. And those of you that maybe are familiar with that, it's called topology. Topology is basically how does data interact with each other in the physical world? Does a road intersect it? Does it come close to it? Does a line touch it? That sort of thing. How does it interact? So that's how you would examine. And then analyze is where the power of the Android SDK comes in, because we do our geographic analysis and we have a lot of API patterns to do analytical spatial processing within the API. And finally, we want to either publish, we want to act on these things, we want to publish maybe web maps, we want to publish Android apps. We want to consume different types of data and apps and web maps in our Android app. So as we go through the presentation, we'll be thinking about what parts of these approach we're using. So we'll start with geographic analysis. And this is essentially converting data into information that adds value from a spatial perspective and answers questions. It's more than just points on a map. We see a lot of points on a map. What's behind that? How can it serve to add value to our application? There's analytical services which we would go through, like line of sight, right? Is there obstructions in my way? How can I analyze that programmatically? There's hardware analytics as well as when we do that, we'll use OpenGL and things like that to help with the analytical process. More on geographic analysis is some things you're familiar with, anyone familiar with mapping APIs now is location. And there's many geocoding locations. Geocoding, for if you're unaware, is a way to take a point and turn that into an address, essentially. Or to take a reverse geocoding, take an address and convert that into some sort of point. In Android, the point might be a screen point, which would then be converted into a spatial reference point, which then can be converted into an address. So these services that we use here provide global coverage of the whole world. They use geo-searching, which is just a way of saying that you don't need to put in the old days. You put in an address in order to get that point or to get that location. Today you can use points of interest. You put just about anything in there, and the technology is able to get yourself a point and location based on it, or at least a list of places for you to choose from. I mentioned reverse geocoding. That's taking that address and giving me a physical location on the earth for that address. And then we also support things like batch geocoding. So I have a list of addresses, and I want them all in one programmatic pattern, programmatic line. I want to go ahead and map those points. That's our batch geocoding. So in today's world, that's a lot of the location services that you'll see out there today. They use that approach. There's a service out there. They do all those fun things, and you go away with it. You got to stay connected. You got to be connected to it. We also support things called runtime locators, and so what that is basically take the engine that creates all of that, all of these conversions from points and stuff like that, and put that locally in the API, and package the data that's required to feed that engine, and you can now start locating and doing searching and routing when you're disconnected, right? Or when you so that just requires everything being on the device, and you can now disconnect and continue searching and routing. From our Android API perspective, the API is exactly the same. It's not an offline API versus a service-based API. It's the same exact API. The difference is how do you connect? Are you connecting to local runtime locators, or are you connecting to a service endpoint URL? Everything else from an API perspective is the same. So in routing, we have a developer pattern that we take that involves pretty standard steps. And that starts with your route task. So your route task is something that's going to actually execute a route. In and of itself, it needs information in order to create that route. So you set up parameters for that route. Parameters such as what's the spatial reference we're in? Are there stops? Are there multiple stops? Where to start and end point? That sort of thing. Then that route task can execute and calculate a route. Right? So you get a route back from your route task. Well, what are you going to do with that route once you have it back? You take those results and you display that route. So displaying that route involves graphic layers and putting it on something that's viewable to the mobile user, the Android user. Furthermore, from the results, we can also get actual directions, and those directions will get us point to point along the route, including the stops. So that's the general pattern. Set up a route test, get your parameters, put in any stops that are required, calculate that route, get the results, display those results, and then if you want, display the directions. More geographic analysis includes measuring distance in an area, and the API that we have uses a self-contained contextual action bar pattern. And so a lot of our tools, and we provide a toolkit that allows you as an extension off the main API. And so that toolkit allows you to bring in these tools very easily integrated into your app or any app that has an action bar already installed. You simply bring in the measure tool that's shown below. You assign it to your action bar activities, or resources, a string, or an action, and then go ahead and implement it in a map fragment or your map activity. It's very customizable, so at the map activity or map fragment level, you can set your units, you can set your distances, you can change the colors, the highlights, and things like that. So it's a customizable geographic analytical tool within the API. And something about going back to acting on it, so I described earlier, we have these services-based approaches where you can create pre-made web maps. And then on those web maps, you can host them in some service. So we have an API that allows you to discover that content and publish that content and then bring it into your Android app. This is a way of using service-based content that allows you to create and discover within the API. So we have an open source app that does just about everything I just described up there. It's out there at that location, and it's a navigation-centric app using the ArcGIS SDK, which I'm describing. And that's what I was going to go ahead and demo that and show you what it does and show you how it extends. What I can do, if we're interested, is look at the actual source. But the app itself, break out here. So to give you a basic idea of the app itself allows you to select base maps based on a portal API. You can go out to a server and get predefined base maps for you to set. One thing that starts with, this is all on a services-based approach. Then you can search, route, do all that level of analysis and measure based on those service-based APIs. What it also allows you to do is go in and log in. And if you log in, you can create your own custom apps. And so when you go select a base map now, your base maps will come up instead of the base maps that are predefined in the cloud. So now you can customize your own base maps, and you can sign into the app and go get those apps. And then use the same functionality out in search, route, even switch the underlying. I'm using base map loosely here. It's really a web map, but you can switch out the base map underneath your web map as well. Still, if you want to do that in your Android app. And this is right here is our authentication class, and I encourage you to go out and look at some of the this application, and it gives you instructions about how to use it. So that is our Maps app. And there was the demo I would have shown. And if you want to see a demo, I'd love to show it to you afterwards. The second part of what I want to talk to you is about a lot of what we just discussed is within your basic navigational apps. We have a full API to do it. It's great. There's other APIs to do the same thing, just with different map types. But same workflows. You go sign in, create your own maps, switch around maps, route, do do all that stuff. Somewhere where we're moving forward is in these offline patterns. And yes, you take some maps offline, which is the simplest thing, but we also have ways to sync back and edit things. We allow folks, developers, or an API to take some features from a service-based feature class or database, excuse me. Take those locally, go ahead and edit them, create new ones, your typical CRUD workflow. Do all that work locally, and then save that work locally, and then synchronize back up to a service that anyone else connecting or using that same map service on another Android device will see your edits and will see your saves. Beyond that, we more down the weeds of analytical analysis of offline is things like routing and geocoding, as I stated before. So you can route on service-based routes, and you see a lot of apps that can do that. But we can take that offline. You go ahead and route anywhere you want offline and do your geocoding or search-based stuff offline. Also, we can do things like, as I stated earlier, line of sight, which is essentially what's if you have an observer point and you move around that observer point, what's blocking the line of sight. And that's so we can do that two ways. There's a service-based, what we call a geoprocessing service that'll allow you to do that same thing, but you've got to be connected to that service, and it's a little bit slower because you're sending back and forth information about where the observer is, where your points of observation is. When you have it local, you can literally drag your finger around, and it's doing it on the fly. That's where we're using the hardware analytics. Viewshed is a similar concept of using an observer point and being able to what is the view shed, or what can they see based on that observer point. Again, two ways to do it: service-based, which again we're sending back and forth to a server, and so it's a slower reaction, or we can very quickly do it locally. So those are new things that are coming out. We recently are releasing. And then the other thing we do is we have extension points to define your own layer and symbologies that you can persist your device. So we have our own, a lot of mapping technologies and GIS folks have their own specifications on how they handle data. We at ESRI have ours. There's other ones out there. There's Mapbox, which has MD tiles. There's OGC-based layers and tile-based specifications, and we try to support most of them. Certainly the ones relevant to our developer base, but we don't support them all. But what we do support is an extension off our layers that allow you, if you understand the spec of that layer, you can go ahead and write in that you can extend our API to support that specification. So we'll take that a little bit further. First, we'll go with offline sync patterns. So this is where the use case where you're taking some information that's on a cloud-based service, and you want to manipulate it, and then you want to persist it back. And so this API will support a large number of users because all the users are getting that information off of a cloud-based service. And now you can take, so data is in a large database, cloud-based database. You could either consume the entire database, which can take a long time to get locally on your device and come with device limitations, or you can take the map extent of where you're at. This is in an app situation, because you can also do this programmatically without a map. But taking the map use case, you can come into an extent, and whatever features are within that extent, or whatever tiles or base maps are in that extent, you can limit your features and tiles to take just that offline. So you have a lot of flexibility with what you're bringing to your device locally and what you're taking from the service. And so this little diagram just shows your little mobile device on the bottom of the cloud and the features and maps that are in that cloud that you can consume on your device. And then this goes back to what I was describing about creating your own layer. layers, right? We set a lot of predefined layers for you. We have our own tile map. I don't know if everyone's familiar with what a tile map is or a vector map. These types of map data that are becoming very popular in the GIS world. So we have a bunch of, we support them all, but we support them usually within our own ArcGIS based, and then some other ones that our developers use frequently, which is like Bing Maps layer, one of them. OpenStreetMap is a very popular open data format that we support right out of the box. If we don't, there are plenty of specs that we do not support. That's where we have a tile service layer abstract class. And that has an abstract get tile method. And under that get figure that out. You can write in the spec to go how to go get that tile. So we have an example of using the Mapbox MV tiles. We have that code out there available for you as an open source, and you can see an implementation on how we extend that get tile and go ahead and bring in some Mapbox files. And this, we're going to do a bunch of offline demos for you, offline routing and offline line of sight and offline view shed. But this map right here is an example of this particular feature set that you're seeing is an extension, and it's an empty tiles map that was extended and brought into our application. And again, I apologize. They said that they would have the casting available for me to demonstrate a bunch of these features that I'm planning to. But that didn't work out this afternoon. So I'll go right to the Android tools. I'll open up some questions, and then anyone interested in looking at some examples of this and our code, I'll be here all weekend, or we can use this fix now and take a look at it. But the tools that are being used here, and I encourage you to go out and play with them and think about how how you can solve some problems locally if you ask yourself at first how does spatial information add value to whatever type of application you're building. And we have what's called an ArcGIS Android SDK that you go down that website right there to download the actual SDK, which will give you plugin support. It will give you documentation, samples, all kinds of stuff, like all the libraries required, that sort of thing. You can also directly go to an Eclipse update site if you're using Eclipse and put that into your site URL and just get the entire SDK that way without having to download anything, just to try it, see what you think of the API. It comes with the Java docs and everything else. We are moving away from the Eclipse pattern and the ANT-based project pattern, format, and moving into the Gradle space, the Gradle project space, and supporting Android Studio. So today, currently, we have an early access program for developers who are already there or who are interested in learning about how our SDKs are migrated over. And so those are two GitHub open source repositories where you can go ahead and get samples right straight away and start playing with them. The library module is there for you. Integrate that with the samples, and you can start using those samples, even extending them if you like, creating your own samples, that sort of thing. A lot of our user base comes. We've been doing this now. I've been releasing Android software since at least 2008, or the lead for Android with ArcGIS since at least 2008, and all of our I've led all of our releases. And so we come from our current developer community is very much based in Eclipse. We provided Eclipse tooling from day one, Eclipse plugins to help you get started and get your projects going. So we have our current user base has a little bit of an migration pattern going. If you come in new, it's really nice to just get started at the Gradle project level. And that about sums up the speaking portion that I had to do today. And again, I'll just reiterate what I went over in GIS geographic approach, and again, just remind you that when you think of, in all of your disciplines that you build Android apps to think about location, whether it's a Maps app or whether it's not a Maps app, I can pretty much think of any way to add location, to add value to most apps out there, from financial to medical to all kinds of things. We have this, in employing this geographic approach, we did things like geographic analysis, and we introduced you a little bit to the Maps app, which is great. But it is out on GitHub, and I encourage you to go play with it, open source it, contribute if you like, have fun with it. And we went over some offline patterns, which really separates us from a lot of Android APIs right now, being able to do very advanced things locally on the device, from analytical, high-powered analytics to base maps to custom engineering files. And then finally, just all the tools that we use to build those apps. And with that, I'd like to thank you and open it up to questions if you have any. And once again, those are some of the ways to contact me. Appreciate it. Yeah.
Is there a simple way to make that function to find a street intersection from the forest or from the street address? Like, for example, Madison, New York, the closest intersection, or between streets.
Yeah, so the question is there an API that allows you to find the closest street to an address? Yes, we do. We have a couple of ways of going about that. We have a geometry engine that can do that, which allows you to figure out where things line up. We also have nearby APIs that are more on the geocoding and search side, which allows you to, if you know what you're looking for, you can say what's nearby. So you have two basic approaches depending on how fine-tuned you want to get that. Anybody else? Yeah. Good. So when you use offline, how big is on the device? But that's dependent on the size that you're taking offline. So our recommendation is you always take the area of extent that you're going to work in, or that you would like. So it wouldn't be practical to take the whole world offline necessarily. But if we have an example of taking like the entire city of San Diego offline for routing, and that is roughly in the 20 megabyte area, I believe. And so you can take urban areas for routing, stuff like that, and it comes down pretty good. When you take instances of the maps, we do what's called a tile package cache, and basically formats that down to be pretty small. So you can get a large area of base map. In fact, we have full base maps that go offline of the world coverage. So it really depends on what type of feature you're trying to bring down and what you're using it for. But you control it programmatically, you control the size, or you can build your app to allow the user to control it. Obviously, you're doing programming behind the scenes, and then you can limit and say, no, this is going to be too big of a. There's another thing that we built in that you can have built in is also a limit on how long data stays offline. So that you're not continually caching all this data and then getting to your limit of your device and going, oh, I never needed that data. So you that's a programmatic thing, it's not by default, that's something you can do as well. Oh man. Financial applications? Right, so you're any ideas of applications that aren't so map-centric? Yeah, absolutely, I've worked on many. Financial transactions always have location endpoints. And sometimes when you route a financial transaction, you'll want an optimized route. You might, A to B might seem really simple, Zurich to New York might seem very simple, and the different stops it has to make along the way might seem very trivial, but when you optimize that with a spatial, not using any maps, you're just using a reporting tool and a confirmation that's going here, but using a spatial tool could efficiently get that money, or that transaction, I should say, from one end to the other much faster, much more efficiently. I've worked on some financial apps that actually, where we do that. Security is another one, where you got to route around certain things, you got to fence certain areas where you have to transact and avoid things like that. So you can do things like fencing to ensure that the route never goes through. Some other good non-spatial apps that come off the top of my head are insurance is another one. So in the insurance industry, you get a risk factor, right? And that's how most insurance companies are going to insure you. Well, to this day, they get to use any spatial analytics on that. So whether you're next to a nuclear plant or whether you're next to a school is all based on zoning. And your actual distance to those is irrelevant. So if you're in a zone with a nuclear plant, but it's 45 miles from you, it's a lot different than if you're in that same zone and it's 5 miles from you. They have no way of determining that, so you get the same risk. So that's another approach, where your distance to something could help then make a much more efficient risk factor for you, if it's in their benefit, of course. Thanks. Anyone else? I got 1 minute. Well, if not, I appreciate it. I hope you enjoy the rest of the conference. Like I said, I'll be here. If you have questions or want to see any apps, just let me know. Thank you very much.